Good evening, principals, coordinators, and spot prelim qualifiers. It's me, Ishita, your host for the VSSF Spot webinars. I hope you have gone through the recorded session, Planets and Beyond, and have raised your questions. But before we proceed, let me please reiterate the housekeeping rules that I shared earlier. This session would last for 45 minutes to an hour. Mobile phones to be on switched off mode. Requesting all the students to actively listen and participate in the session. Questions from this session could be a part of the SPOT final exam, except for the SPOT basic students. Please do not doodle on the screen, chat, nor spam. If found otherwise, we will be restricting your participation from this webinar. Respected principals, teachers, and students, it's my pleasure to introduce and welcome Dr. Sreejith AJ from Erwin Schrodinger Laboratory for Atmospheric and Space Physics. We have Dr. Sreejith with us today to answer your questions. We are overjoyed to have you with us, sir. Now may I invite Dr. Sreejith to address our spot qualifiers. Many questions, but limited time restricts our speaker from taking all the questions. Speaker has shortlisted few relevant and contextual questions that was received. Please note, questions that are similar in nature have been clubbed to a single question. Our endeavor is to ensure that you get better clarity on the topic, planets and beyond. Now let's straight get into the Q&A session on planets and exoplanets.
Good evening, sir. Thank you for giving me this wonderful opportunity to clarify my queries. So, sir, my question is that can gravity on exoplanets change our body structure? If there are any other races on exoplanets and if they are far more advanced than us, would we survive?
So, not just exoplanets, gravity indeed has an effect on our body. So, for example, for astronauts who have been on, so if you have seen videos of astronauts in moon, they kind of like hop around, right? So, for example, if one of us was born in Mars or moon, and we live for a long time there, and that would mean that our body is used to that gravity, and when we come back to Earth, it would have an effect on us. So it's similar to how people who lives on, say for example, high altitude, who lives on the mountains, have better lung capacity compared to people who live on the ground, because the density of the air is different. So depending upon the surroundings, so the gravity would indeed have an effect on it. So if someone who is born on an exoplanet with different gravity, they would have issues. So for humans, it's also a question of whether we'll be able to withstand the gravity. So humans can kind of like withstand gravity that is like 3 to 4 times more than our gravity. So if the gravity is more than that, it may be really hard for humans to withstand. So anything below 3 to 4 times would be fine for us. So regarding other races on exoplanets, there is something known as Kardashev scale, which is kind of like a classification for how advanced a civilization is, or a race of civilization is. So humans are, so the lowest rating is class 1, where it is assumed that that particular civilization is able to harness the entire energy that is coming out of their star. So humans are not at that level yet, because like we don't utilize the entire energy that comes out of sun, right? So that's like the civilization 1. Civilizations 2 is a planet that can, or is a civilization that can extract or use the entire energy of the star, not just that is given out by the star, but kind of like squeeze the star and take out whatever energy it has. So that is civilization 2, and civilization 3 is something that can do it across multiple stars. That's like around galaxies, and civilization 4 is beyond that and so forth. So for each civilization, the other civilization would be like, so it would be similar to how we consider ants. For us, ants are non-consequential, so we can kind of like stomp our ants and doesn't care about it. So each civilization, for them, the law of civilization would be something like that. So if we get into a fight with one of those civilizations which are really advanced, we may not survive because we don't have the resource as of now. But it can change anytime. Like if you are more advanced than them, like we may be the one who are surviving. So it depends on the context of, or it may be also that we may not actually care about it. For example, when you go for a walk and you see a colony of ants, you don't actually decide and go to destroy the ants. Right? You're like, okay, it's there. Like it's not something that I have to be worried about. So you don't care about it. So in principle, they may not actually care about us as well. So it depends on the situation there. I hope your question it's clear for you.
Sir, my question is clear. Thank you.
You're welcome.
Good evening, sir. My question is, how do we discover exoplanets although they are so small and reflect very little light?
So as I mentioned in the talk, so there are like multiple methods that we use. One is called radial velocity method. So in this method, what happens is that when exoplanets go around the star, because of the gravity of the exoplanets, what happens is that the star kind of like moves around a little bit. So we by looking at the spectrum of the star, we'll be able to see this small movement, and that helps us to actually find whether there is a planet near the star, and that helps us to measure the mass of the planet. So another method is called transit method. So when a planet passes in front of the star, because of the presence of the planet, the starlight comes down. So if we measure the difference in starlight with respect to before a planet is passing and after and during when the planet is passing, we will be able to understand how much starlight is lost. And with that, we can kind of like understand how much is the radius of the planet, because it's kind of like directly related. The amount of starlight we lose is directly related to the size of the planet. So these are the two main methods. There are other methods. If you can go back and go to this, like methods like direct imaging, where we kind of like block the starlight and see whether there are planets around, stuff like that. But the best two methods we have are transit method and radial velocity.
Thank you, sir.
Thank you, Sham Shankar. To the attention of all the students who are asking the question, students are asked to introduce themselves with their name, class, school, and state before asking the question. Thank you. Over to Suryanshi.
Good evening, sir. I'm Suryanshi from class 8 and from school KV number 2 of Noor. Sir, can you please explain about the wormholes and the black holes?
Okay, so black holes are kind of like objects which are at the last stage of a stellar evolution. So when bigger stars, not like stars like sun, but really big stars, massive stars. So during their life cycle, they turn into something known as super red giants, and then they kind of like explode as supernovas. So whatever remaining inside the core of the star, because of the gravity is so strong that they can turn into two things. They can either turn into, say, something known as black holes, or they can turn into neutron stars or white dwarfs. So black holes are things where like the gravity is so strong that even light cannot escape. So what happens is that, so you know that light is something which is kind of like emitted from stars. So if the gravity is so strong, what happens is that even light wouldn't be able to escape the gravity, and light would be trapped there. So you wouldn't be able to see the black hole. So the only way in which you can see the black hole is by how things move around that. So for example, when you kind of like open your tap and you see the water going down your drain, you see that it goes in swirls, right? It goes down. So there is a region inside where, like, for example, if you put a small paper or a leaf, you know that this goes around the swirl like this. And then what happens is that at some stage, it kind of like goes inside. So what we do to understand black holes is that we look at objects, and when we see that this pattern of things moving around it and then going inside, we can know that there is a black hole there. And if it goes inside a particular limit, it won't escape. So if you can do this black hole experiment in your ground, you can open your tap and then you see the water going down inside. Then what happens is that, like, at certain limit, you see that things cannot escape from that. It's kind of like trapped in that. Even before that can escape. So that's why they are known as black holes, because like it's black, you can't see what is happening, and it's kind of like hole because things go inside. So wormholes are kind of like a theoretical concept. So what wormholes are? It's a theoretical concept. We haven't actually observed a wormhole so far. So what wormhole is that? It's like it's so assume that your space time is kind of like, so my hand or a paper or anything. So it can be curved, right? So wormhole is something which connects two parts of your space time. So it is connecting two parts of the universe, but it's something which is like theoretically proposed. It's not something which we have observed so far.
Okay, sir. So can black holes be any type of wormholes?
No, these are two different things. Like so, in principle, so in theory, there may be theoretical solutions where the black hole solution and wormhole solution match, but we haven't observed any wormhole so far. So I hope that answers the question.
Okay, sir. Can I ask one more question regarding it?
Yeah.
So how can the space-time be bent, folded?
Oh, okay. So assume space-time is like a stretch rubber sheet, or your cloth or whatever. So for example, if you for people, okay, everyone in your home is holding like everyone is holding into the bed sheet you sleep, and you kind of like put a big ball in the center of it. So when you're holding it tight without putting anything in center, is kind of like flat, right? So when you put some heavy object like a ball in the center, it kind of like goes down, right? It will have a shape because the ball has some weight on it. So this is how space-time is. Like space-time is affected by of the mass of any object. So you have a mass of any object. So the gravity kind of like the object, how massive it is, it kind of like changes the shape of the space-time. And so in principle, so you have multiple objects, you kind of like change the shape of your space-time in that respect. I hope that is understood. That it is
Yes, sir.
clear.
Thank you so
Okay.
much.
Good evening, sir. I'm Abhas Kumar Singh of Class 9th Pacific World School, UP. My question is that in the video you mentioned in that earlier session that the red part of flame of candle is the coldest part and the blue part is the hottest part. And even in stars case, it's the same. But in real life, why do we depict the hot things with red and cold things with blue?
Okay. So so it's so we kind of like assume red to be more hot because like red to be warm, hot, etc., and blue to be cool. It's a perspective thing. Like we find cool to be calming. It's a human thing. But another thing that you have to also notice that even though the hottest part, like hotter things are blue, like in real case, what what actually what actually is that the color also depends a lot on the materials that are present in it. For example, when you have firecrackers which you use for Diwali, or for whichever festival you use, or New Year, you use firecrackers for different functions, right? So they have different colors, right? Those colors are not only imparted by the temperature of what is happening there, it is also by the materials present. So for example, different things will give different colors. Like for example, if I'm right, copper would give it a blue color. uh, I think ions give it a red color. So different materials that are present will also give different color because different. Excuse me. Can you repeat? Yeah. So depending upon that, the color also changes. But what I was talking about was like a black body. So black bodies are things like if the light coming out of is only because of that particular, if burning something, then the color depends exactly on how hot or how cold it is. And hotter things would have a bluer color, and redder things would have lower temperature.
Thank
it
you,
clear?
sir, for clearing the doubt.
Okay.
So, sir, I'm Satyaditya Akella of class 9 TA Public School, Telangana. Sir, we have many planets outside of our solar system which reflect light. I learned that we capture that light and estimate the distance between them based on the redshift in the light. But due to warping up of space-time based on Einstein's relativity, it may cause the light to travel a more distance, which increases the redshift. And even due to gravitational lensing, it may cause the same object to appear in different regions at different times. So is the distance measured between them accurate?
So the redshift is actually there's two things. Like we use redshift and blue shift to measure distance of galaxies and stuff. For exoplanets and stuff, like we kind of like use other methods to find the distance. There's like methods like parallax and stuff like that. So that's what usually used to measure distance to exoplanets, because most of the exoplanets we have discovered so far are within our galaxy, nearby us. So it is like easy to observe them with parallax. And within that short distance, the issues of redshift affected by space-time it's like very negligible, and the distance we measure would be it is not something which would be affected by the measurement errors would be much less considering space-time. So it's not a factor here. But for galaxies and stuff, it's like a factor. So you kind of like have to do some corrections if you have to do that. But galaxies are really far off, and for them we use redshift to measure them, to measure the galaxies, and we usually code the distance of a galaxy based on redshift. But for exoplanets, it's not the case, because we don't usually use redshift to measure the distance. We are using this redshift and blue shift to the planets to find if there are planets around stars, and not measure the distance between.
Okay, sir. Thanks.
Okay.
Thank you.
Good evening, sir.
Yeah. Good evening.
Good evening, sir. My name is Amlan Jyotipati. I read in DAB Public School, Sambalpur, Odisha. My question name is, what are exoplanets?
So any planet that goes around stars other than the sun, they are known as exoplanets.
Thank you, sir.
Good evening, sir. My name is Anusha. I'm from Delhi Public School, Bangalore East. My question is, how was the universe created?
So our current understanding is that universe was created during something which is known as Big Bang, like that's like the universe just exploded and came into being.
But sir, I recently saw something that said that the Big Bang theory might not be true.
As of now, Big Bang theory is the best idea that we have of how the universe is formed. But there are other theories which I proposed. But as of now, Big Bang theory is the best one which answers all the questions that, or most of the questions that we have of how the universe is formed.
Good evening, sir.
Good evening, sir.
Good evening, sir. Mine.
One person
Good
at a time,
evening,
please.
sir.
Yeah. This is Chaitanya of Global Indian International School, Hyderabad. So my question is like, what are the biggest favorable conditions for life on exoplanets?
Okay, so as of now, we are looking for life on exoplanets which are similar to ours. similar to us because that is what we understand better, right? So we understand how life is on Earth. So we are looking for things which are similar to similar. That's that kind of life on exoplanet. So for that, the main contributor, as you know, are there should be oxygen, there should be atmosphere, like our atmosphere, similar to atmosphere where there's like enough oxygen. There should be liquid water because liquid water is essential for life on it. And there are other elements that we know which are indicators of organic forms, like methane. There should be some amount of carbon dioxide. There's like some amount of nitrogen that is required. So because the life forms which understand are in the form of hydrocarbons. So for that, like for liquid water to exist, the planet should be at a particular distance from the star, right? Because like if the planet is really close to the star, because of the temperature, what happens? The water would evaporate and there wouldn't be any liquid water. If it is really far, the water would be in ice form. So we need to be at a certain distance from the star, so where liquid water can exist. We call that regions habitable zone. So if the planet exists in that zone, it would mean that liquid water exists. And then we start looking for these planets if they have an atmosphere, if the atmosphere has oxygen, if the atmosphere has other gases that we know that indicates that life. And if we know that, then if we find those things, then we'll start looking at other things, like if we can see indication of chlorophyll because of the planets, of the plants, if we see chlorophyll, if we see anything else, that is like indicating of life. So these are the things. So the biggest problems in detecting exoplanets are, as I mentioned, like it's like really far and it's like really small. So habitable zone exoplanets are even more difficult because like we have to meet that condition of planets being in that particular region around the star, and then they also have to have these elements. So it's like a continuous observation. And as you know that, so if you are observing, so to observe atmospheres, the only method we have now is that now is called a transit method, like where we look at the atmosphere through when they are sunset or sunrise. So the problem with that method is that transit happens with respect to the period, right? So for example, Earth takes 1 year to go around the sun. So most of these exoplanets which are in the habitable zone may take, Earth-like planets may take a longer time to go around the star, because the closer the planet is, the faster it goes around the sun, right? So the further away it takes more time. So you may require one, you may get only one observation per year. So you may need multiple observations. So it will take multiple. So time is also involved to observe such a planet to understand the atmosphere. I hope it's clear for you.
Yes, sir.
Good evening,
Thank you.
sir. I am Ashwat Akilan from Mahatma Global Gateway, Madurai, Tamil Nadu. So I have 3 questions based on exoplanet. How big does a star have to be for a planet to orbit around it, sir?
So we have actually observed planets around different kind of stars. Like, so there's no condition as of now of how big the star should be. We never expected. We expected planets around sun-like stars, but we never expected planets around bigger stars, massive stars. But we are finding planets around them as well. So it's kind of like. So we have found planets around different kind of stars. So I don't think there is a condition of like how big the star should be.
Okay, sir. So my second question is, what substance are exoplanet made of? Like you said, Mercury to Earth, Mercury to Mars is rocky planets, and Jupiter to Uranus is gaseous giants.
Yeah, so for exoplanets also we see gas planets, we see rocky planets. So it depends upon the planet and where it is going around the star. So we see gas planets, ice worlds. So depending upon the planet, all similar to what we see and different from Earth, different from solar system, we see different kind of planets. We see so most of them are like most of the elements are that we expect to see as you see them. Most of the gas plants are usually made mostly of hydrogen and helium, as you expect them to be in solar system. So rocky planets, you see rocks of silica. Sometimes there are metals in them. So it depends on the planet. Yeah.
Okay, sir.
Good
My
evening,
doubts are
sir.
clear. Thank you, sir.
My question is.
Good evening, sir. My question is
My question is
that
why
how are
is
constellations
why
formed?
Saturn has so many rings?
Sir, how is constellations formed?
One person at a time, please. Like I can't answer.
Sir, actually,
I
Sir,
can,
my
without
name is my name is Akash Hegde.
My question is.
I am from Bangalore, and
My
I would
question
like to know
is
how
Excuse-
are
why Saturn
constellations
has
formed?
so many rings?
Excuse me, please hold on, all of you. You know, when everybody starts speaking, it doesn't, nobody can hear. That is the situation, right? So we have put an order. We request you to kindly follow that order first. After that, you know, when there is a chat box, you can post your questions in that, and answers will, you know, if there is time permits, you will be given a chance to ask. Else your questions will be answered in written. So please cooperate. Otherwise, we all will be, you know, going in circles like this. I hope you understand. That is, I think you can proceed. I think the 8th question has to go on. So Samiksha Banerjee, you may ask your question now if you have not asked. So I request all of you to, you know, hold on till your turn comes. Yeah, please proceed.
evening, studying at my question is that why do we prefer to use reflector telescopes instead of refractor telescopes, and why are the telescopes of various shapes? Because they perform the similar tasks.
Okay, so we prefer reflector telescopes because it is easier to build mirrors rather than lenses. So the problem is that if you build bigger lenses, what happens is that after a certain size, you know that glass, even though it looks solid, it's not actually a solid material. It's kind of like amorphous. So after a certain size, what happens is that if you have a lens, even though you build it with one property, because of gravity, the shape, the lens, the material inside the lens would slightly change, and you won't get the good. And it is like really difficult to handle big lenses. That's why we build mirrors. So, and why they have different shape is that usually telescopes are made in the shape of hexagon, because if you know, hexagons can be joined to form bigger hexagons, and then you can join them to form bigger hexagons. So you can join hexagons together and form bigger shapes of different size. So that's why telescopes are usually built with hexagons. And then we need telescopes of various sizes, because the bigger the telescope sizes, the more light you can collect. The more light you can collect, it is you can see fainter objects. That's the reason why we build bigger telescopes. I hope it's clear.
Yes, sir. Thank you, sir.
Good evening, sir. Sir, I am from Delhi Public School, Bangalore North. My question is, what is loopholes?
1 second. The question was supposed to be from Arnav Mishra, so I think I'll go.
Good evening, sir. I'm Arnav Mishra. Sir, can you hear me?
Yeah.
Okay, so I'm from class 9. I'm from Uttar Pradesh, precisely from Pacific World School. So my question was, why are hydrogen and helium not considered metals in the astronomical periodic table? Also, is there a reason why these elements are found in such large quantities?
Okay, it's just so hydrogen and helium are the most abundant elements. So whenever we speak of hydrogen and helium, we call them by hydrogen and helium, and that's why they're like, so metals is just a way of clubbing everything else together for ease of communication. So whenever anyone speaks, they'll say hydrogen, helium, and metals. So it's like everything else is metal. That's all. We because these are individual elements and they are like very high in quantity. That's why we call them by name and everything else by metals. So the reason they are found in large quantities is because hydrogen and most of the helium, a fair bit of helium that we see in the universe, was actually produced during Big Bang. So that's when actually hydrogen was produced, and then helium. So any other element that we see in the our universe is produced in stars and during the supernova explosion. So what happens is that if you know what nuclear fusion is, where elements of smaller size or smaller mass, they come in together to form bigger mass elements. So two hydrogen atoms can form helium and hydrogen can likewise. So you can have higher mass metals from higher mass elements from smaller mass elements. So these are produced in the stars. So so initially the older stars were all of hydrogen and a few little bit of helium. So as we move further, like as the universe gets older, we'll have more and more elements, and the amount of hydrogen helium may come, like, because they are getting converted to metals. So that's why we have a lot of hydrogen helium, because these were formed during Big Bang, and that is what most of our universe is made of.
Thank you, sir. The answer was really helpful.
Okay.
Good evening, sir. I'm Adrita Lal from class 4, MD Devi.
No, I think, can you stop? Like, I think I'll go through the questions which are posted here, and then I can answer your question. So it will be Vigneshwaran, question number 10.
Okay, sir.
Ishan. Ishan. Ishante. இந்த முதல்ல வெயிட் பண்ணிருக்காங்கன்னு நினைக்கிறேன். இந்த முதல்ல எனக்கு வெயிட் பண்ணிருக்காங்க. என் क्वेश्चनலாம் ஃபர்ஸ்ட்ல வந்துட்டு இருக்கு. இவங்க இவ்வளவு கேவலமா கேட்றானுங்க பாரு. நீ எத்தனை மணிக்கு அனுப்புறதுல யூஸ். ஓ அப்படியே.
Audio in mute. Please keep your audio on mute. And the one asking question number 11, Samika, if you are there, you may ask your question.
Good evening, everyone. I am Shamika Abhaysia Raut, 5th grader from Dr. Kalmadi Samara High School, Pune, Maharashtra. My question was, can we observe the Doppler effect on different planets which have no atmosphere?
Yeah, so the atmosphere doesn't have anything to do with Doppler effect. Doppler effect that we observe is because of the gravitational effect between the planet and the star. So if the planet is massive, like, it will have much more higher gravitational effect on the gravitational effect that we have is depending upon how massive the objects are. So if the planet is really massive, then it will have a higher gravitational effect on its star, which will cause the Doppler effect, and then we can observe it. So it doesn't have anything to do with the atmosphere.
Sir, but as far as I know, we can't observe sound on in space.
Yeah, like, so, but Doppler effect is not just limited to sound, but it can affect light as well. So it's just so I use sound as an example because it's easier for us to understand for us, because like so to understand Doppler effect, sound is an easy tool, but Doppler effect is something which affects light as well. So you can see Doppler effect on light as well. So, and that's how we use that. So it's Doppler effect on light that we observe, and not Doppler effect on sound.
Okay, sir. Thank you.
Hello, sir. I'm Shivanandana from Kerala, studying in class 11th of Kendriya Vidyalaya, Shift 2. So my question is, how to achieve our dream to reach beyond the limits that is in the space? Kindly guide us, sir.
Can you elaborate on the question? It's not clear to me. What do you mean by limit that is in space?
Sir, I just mean that like how to travel in space, that is how to join our space research centers, or is there any type of like
okay, so so it depends on what you want. So so if you want to travel in space is one thing, like studying about space is another, and building instruments for space is a different thing. So if you want to study about space, that is like astronomy. So what you usually do is that after school, you can study either physics, chemistry, maths, or engineering, and then you follow it up with your master's and then a PhD, and then you kind of like do research on astronomy. So you study these objects. So if you want to build instruments, you go on a similar route. But when you start doing your PhD, or when you start working, you kind of like choose jobs that are in space agencies, or you start building instruments. So there are PhDs which would allow you to build instruments for space, and there's also PhD that would allow you to build instruments for ground-based observation. So if you have to travel to space, there are two options. Either you choose a space agency and work for them and hope that they choose you, or you make enough money that nowadays you can pay for going to space. So these are your options. I hope it's clear for you.
Yes, sir. Thank you.
Okay.
Good evening, sir.
Yeah.
Good evening, sir. My name is Krishanu Kashyap of class 8, Kendriya Vidyalaya AFS Borja, Assam. So my question was, why all planets in our solar system always move in anti-clockwise direction?
Okay. So that's not all planets in our solar system move in anti-clockwise direction. So for example, Venus move the opposite way, and Uranus actually spins on its axis. It's like perpendicular to everyone else, like for some weird reason. But what happened? So that is like an exception. So what happened? So what would I? It's not because of any particular reason, but it's because of just chance occurrence. Like when our solar system would have formed, things would have started moving anti-clockwise, and it stayed that way. That is, I think that is the only reason. That's the reason why everything in our solar system moves in that particular. Just because of chance. The only reason Venus and Uranus would have been is different is because they would have been affected by some collision that kind of like changed their path. So everyone else just followed the way things started in the past. That's all.
Thank you, sir, for clearing.
So, uh, so my name is Agnivesh Mitra. My doubt is that is it true that Mars had water canals? If true, then how did it form?
So it is assumed that like there was, our assumption is there would have been water flowing on Mars in the past that would have caused this. So and it's still present there. That's all. Like so, for example, even if you see a dry, so for example, if you go and look somewhere where there was like water flowing and water is not flowing anymore, you will see the channels, right, even now. So and the erosion has not prevented things from moving away, or the winds haven't eroded it. That's why we still see that. That's all the reason. I think I'll take question from Bhakti. If Bhakti is still there.
So good evening, sir. My name is Bhakti Joshi, class 8, studying in Nirmala Convent School, Rajkot, Gujarat. My question was, what steps we should take care to maintain clean and healthy solar system? Please explain the planetary protection policies.
So the main planetary protection policy is that because humans are going out into the solar system and bringing things back, there are like it has two main conditions. So the two main things about is that we don't bring anything back into Earth that can affect us, like that has an adverse effect on human beings. So the idea is that anything we bring from outer space, we are really careful in. So we kind of like has certain set of policies of how we look at whether there are any problems that it can create to human beings, and then they're kind of like stored in a safe environment, are really careful to handle with it. Another thing is that we also make sure not to contaminate any of the planets. So if you go there, it's like assume that we shouldn't leave anything there that is like harmful to those planets. So that's the two main ideas of planetary protection policy as of now.
Thank you, sir.
Yeah.
Good evening, sir. I'm Sridhanya from class 8.
I think the question is supposed to be Bhavin. So I would take Bhavin for the questions, and you can ask the question after session is over.
Okay.
Bhavin. So maybe I'll answer Bhavin to the questions about supernova explosions. Supernova explosions happens all the time. So supernova explode because like these are massive stars which can't hold itself anymore, and like the process, the equilibrium that is keeping the stars is not there anymore, and kind of like explodes. So supernova explosions happens all the time. But the most of the supernovas that we see recently are from distant galaxies. So the recent supernova maybe, I don't know, I haven't checked the there's something known as supernova telegram where people kind of like update on the nearest the recent supernova explosion that they observe. So it may be yesterday, or it may be day before yesterday, or it may be 1 week back, but I don't know which was the nearest explosion, but it happens all the time.
Good evening, sir. My name is Shashank Bhardwaj. Sir, I am from UP. Sir, my question was, how was universe created from Big Bang?
So it's just that there was an like Big Bang. It seemed that like before that there was nothing, and then there was the universe just exploded from. That's why we call it the Big Bang. So that's all. We exactly don't know how that thing happened, but we know that it just exploded and happened. So we are still trying to find out how universe was exactly created.
Sir,
So I
because
think
because matter cannot be created nor be destroyed.
yeah, that so that's assuming that that is after that is in our universe, right? So when universe is created, it's kind of like everything is different there. It's like it's when universe was created. So you have to if you're talking about creation, so you don't know whether there was a universe before that, there was a universe after this. So it may be that the universe was created from a previous universe. The universe may not have been created. So it just exploded. So it may be that there was some really small thing that exploded. We don't know that answer. We are still trying to find it out. But I think I'll answer this question. Can we create artifacts with same mass and function that will go to infinity without dying out? As of now, we can't. So because stars usually use the energy from the stars comes from something known as nuclear fusion, and we still haven't been able to properly control nuclear fusion as of now. So we can't do this as of now, but it may be possible in the future. Yeah. Next question.
Sir, how do we make how do we like create how do stars form in the first place?
So stars are usually formed from what? So what happens is that there's like a lot of clouds and gas of material. Then what happens is that they kind of like interact with, they kind of like constantly, there's like gas everywhere and they're kind of like bumping into each other with extreme force and everything. So what happens is that then they kind of like go around each other, and when they go around each other, what happens is like gravity starts to form, and slowly by slowly all this matter comes together, and slowly by slowly they form a bigger ball of gas, which is called as a protostar, and then they kind of like again this process continues. Then what happens is that because of these collision with each other and high temperature, nuclear fusion takes place and it starts to heat up, and that's that kind of like how stars form.
Sir, I have another question.
1 second, I think I have to ask this question and then I can come back to you later.
Namaste, sir. Namaste, sir. I am Sreejith of class 11 from Saraswati Vidyaniketan Central School, Kerala. And my question is, which method provides most accurate results in finding exoplanets?
So as of now, different methods have different advantages. The radial velocity method is really good for measuring the mass of exoplanets. So it can give you really good mass estimates for exoplanet. But then you have issues with finding the radius of exoplanet for exoplanet. It's not easy to find radius from radial velocity method. On the other hand, transit method can give you good indicators of radius of the exoplanets, but it has an issue providing mass of exoplanets. So different methods have different advantages, and we don't have any method that would give you all these informations kind of like accurately. So all these methods have their own advantages and disadvantages.
Thank you, sir.
Yeah.
Good evening, sir. I'm Yatin Esai. I'm studying in Delhi Public School, Bangalore North. I'm studying in 10th grade and I would like to raise a question. What is the role of cosmic rays and nuclei atomic particle in formation of supernova remnant?
Supernova remnants are things which are left out after a supernova explodes. So usually, so when supernova explodes, there will be high energy radiation that is coming out of it, which can be in the form of cosmic rays or other energetic particles, because it's like it's the star exploding. And sometimes what happens is that when these things explode, things can happen that they may remain in a state where, because the center of these things can go back into being neutron stars, pulsars, black holes, etc. So then what happens is that if they go into black holes and they're kind of like consuming the metals which are nearby them, those materials can also be ejected out as high energy particles. So I hope that answers it.
Thank you, sir. I would like to add on is, can we prove gravity using quantum mechanics?
There has been research going on that field, but as of now, those are two fields which are difficult to interconnect in these using the models of things that we have as of now. gravity and quantum mechanics, something which we are not able to connect as of now, but it may change in the future. Yeah. The previous question, I didn't answer question number 18. Yeah.
I am actually, sir, I am Param Vyas from class 6, Gujarat. And my question is that how do we know that the universe is continuously expanding at this rate? And can we see the map of universe at this present age?
Okay, so for the first question, so we know universe is expanding because it's an accelerating expansion. So for example, if you're going, so for example, assume that you're going in a car, and if the car next to you is going at much farther speed than you, you would know that because it's moving away from you, right? Similarly, when we look at galaxies around us, we see that the galaxies around us are moving away from us much faster. So they're like moving, they're not like at a constant speed, but they're like moving faster away from us. That's why we know that the universe is expanding.
Okay,
so the map of the universe is like, we don't have exactly the entire map of the universe. It's like we can theoretically produce it, but we can't map the entire universe. What we have is we can have the oldest image of the universe, which is kind of like known as the cosmic microwave background. So that can be said as like universe of the past, but we don't have a map of the universe of the present age because light takes time to reach us, right? So the further we look away from us, we are looking into the past of the universe. So what we are seeing would be like something which is like in the past. So we can't actually see a map of the universe that's in the present age. So whatever we see is like from some time back in the universe.
Okay, sir. Thank you, sir.
Yeah.
Good evening, sir. My name is Nakshatra Garg. I'm in class 6. I'm from Bharti Vidya Bhavan Vidyashram School, Jaipur. My question is, do all other planets have tectonic plates in a solar system like we have on Earth?
Oh, I'm not entirely sure. I know that there are volcanoes on Mars. So I hope there is tectonic there. I know there is tectonic activity happening in some of the moons of Jupiter and Saturn, but I'm not entirely sure whether that is like across all planets. So these are some examples that I know. Yeah, question number 19.
Sir, my name is Rohan Greg Matthews. I'm from class 7 from St. Peter's Senior Secondary School, Kerala. Which is the farthest star discovered?
Oh, the farthest star discovered is called Erentel. So it was discovered, I think, last year by Hubble and confirmed by James Webb Telescope.
Thank you, sir.
Hello, sir.
Sir, my name is V. Pevandoja. I'm from class 7.
Can you stop 1 second? I think it's B1 Roger who has to ask the question.
Sir, it's me, sir. I am only Pevandoja.
Oh, okay. Yeah, sorry, B1. I couldn't hear you properly.
Yes, sir. So I am B. Bevandoja from class 7 Santa Maria Matriculation Higher Secondary School. So my question is that true that Milky Way galaxy is going to collide with another galaxy, because they are telling that the galaxy is moving in a speed of 5 light year per year?
Yeah. So Milky Way galaxy is on a collision course with Andromeda galaxy. If it's going in the same path, it will collide with it in, I think, 4.5 billion years. So that's like really far into the future. But yeah, it is true that Milky Way galaxy is going on a collision course with Andromeda galaxy. Yeah.
Good evening. Good evening. Good evening, sir. This is Veena from Mahatma Global Gateway CBSE, Tamil Nadu. So I would like to ask a question that whether the explosions of supernova, can they affect a person's health in Earth?
I don't think so. Like if our sun is exploding as a supernova, it would definitely kill us. But somewhere far in the universe, it's not going to affect us.
Okay, sir. Thank you, sir.
Yeah.
Good evening, sir. Sir, myself Ujjwal Upadhyay of grade 9 from Kendriya Vidyalaya AFS Thane. My question is, as we know, the moon is drifting away from the earth by some measure every year. How is it possible, sir? And if this can happen with the moon and the earth, can't the same thing happen with the earth and the sun?
Oh, I didn't know about this. I didn't know that the moon was drifting away from Earth.
Sir, I have read in a news article that it is drifting about 24 centimeters every year.
Why is it happening? I don't know. I have no idea. I haven't heard or read about it. I'll have to actually read about it.
Okay.
Okay. I
Hello,
have no
sir.
idea.
Hello, sir. I'm Danush from Mahatma Global Gateway in Tamil Nadu, Madurai. So I have two questions. So the first question is that galaxies look stationary, but why do scientists say that they rotate?
Because like we see the rotation of the galaxies, like we can observe them. It just appears stationary. Like for example, you are on Earth. Do you think Earth is rotating? Like it's like stationary for us, right? So it's like a perception issue, I guess, that we don't see them rotating, but they do rotate because like you can actually see the rotation of the galaxies if you observe them continuously. Or like for example, sun, it appears stationary to us, but we know that the sun moves around, and if you observe continuously, you can see the slow rotation of the sun. It's just a matter of perception. That's all.
Sir, and thank you, sir. And my second question is that does every black hole have a singularity?
Yeah, black hole should have a singularity.